So hello, my name is Annie Conway, and today I'll be talking about dehydration. And within this lecture, I'll talk about what dehydration is, a mechanism, a sample problem, as well as how it relates to health and wellness. So, what is dehydration? And dehydration is when hydroxyl group from one molecule combines with the hydrogen from another molecule to release H2O. This can also be seen with a molecule like oxygen from another molecule reacting with another molecule with two hydrogens as well to form H2O. But in today's lecture, I'll talk about dehydration of alcohols, and this is when an hydroxyl group from a molecule reacts with a hydrogen from another molecule to form an alkene. And so, example mechanism would be having this molecule. And the first step is to protonate this alcohol group. So you'll react it with the molecule with a hydrogen. So this could be anything. And then what it will do, this oxygen will grab this hydrogen and put those electrons onto this to form this. Now that this has a positive charge, it is a good leaving group, so this will leave, and then it will form this carbocation. Okay, so in dehydration reactions, the nucleophile will come in and attack the adjacent hydrogen, which will then form a double bond. So we have this good nucleophile, and these electrons will grab this proton and put these electrons here to form this molecule. With dehydration reactions with alcohols, there's three rules. And the first rule is to protonate the alcohol. The second rule is to form a carbocation. And the third rule is to form an alkene. So with primary alcohols, you use an E2 mechanism, which there's no formation of carbocation, and then with secondary and tertiary alcohols, you use an E1 mechanism, so there is formation of carbocation as well as possible rearrangement. So for example, you have this primary alcohol, and you react it with, you can either use H3O+, sulfuric acid, and you will use heat, which acts as a catalyst for the reaction. So what this will do will form an alkene, and the product would look something like this, as well as secondary alcohol. You react it with H2SO4 and heat, and you will form this molecule. And this is formed because when you do the carbocation for this, the positive charge is right here. And so looking at it, you have a secondary carbon right there, a secondary right here, and this is a secondary carbocation. So there's no need for rearrangement due to the fact that you're not going to a tertiary carbocation. Now, first sample problem, there's this molecule. And with this, we can react it with H3O+ to protonate that alcohol. So what will happen will be the electrons from this molecule will grab this hydrogen, putting these electrons onto here, which will form this. So now that we have that protonated alcohol group, it will leave. and then we'll form something like this, a carbocation. Now when looking at this carbocation, it's on a secondary carbon, and then you have a tertiary carbon right next to it as well as a primary carbon. So you want the tertiary carbon, and since this is secondary, it will follow an E1 mechanism, so you can do rearrangement. So with this hydrogen right here, you can perform a hydride shift, which means that you will take this hydrogen and move it up to where this positive charge is, and the positive charge will go down to where that hydrogen was, making a stable carbocation. Now with dehydration reactions, you want to extract the adjacent hydrogen. So you have a hydrogen right here, as well as one right here. And you want the most highly substituted double bond. So when looking at this, you have a secondary hydrogen, and you have a tertiary hydrogen. And you always want tertiary. So with that being said, you take H2O. You grab this proton. These electrons will go down here, and you'll form this molecule. And with dehydration reactions, it relates to health and wellness through amino acids. So when looking at the structure of amino acid, you have this. And in this dehydration reaction, you'll have this hydroxyl group and this H combining, and it will release H2O, and it will form a peptide bond in between these amino acids. So your product will look something like this. And according to amino acid studies, amino acids are very essential for metabolic processes, and as well with these peptide bonds you can form proteins, which are known to be good sources of transportation as well as storage of nutrients.